Welcome everyone. Today we'll talk about something very interesting. I've been looking into the new Docker Cloud Build feature. I thought that inviting someone from Docker would have made my life easier because I have so many questions. There will also be a demo. Welcome, Marco, and how are you? Please introduce yourself.
Thank you, Francesco. So my name is Marco, and I'm the engineering manager for Docker Build Cloud product. So I've been here since the inception, since we started brainstorming the idea and started working on the proof of concept. Thanks for having me, and looking forward to sharing more or everything I know about this product.
I think you are the right person to ask this. What is Docker Build Cloud?
Docker Build Cloud is a product that improves the speed of your builds. That is the main value proposition of the product. It consists of cloud-hosted builders, build kit instances, which you can connect to from your local machine or from your CI workflows, as we'll see later, and run your builds in a shared cloud builder in a dedicated machine, actually a group of machines, as we'll see later, and also collaborate on your builds across your organization, across your team, get some insight in your teammates' builds, and also benefit from their builds. That's an extremely brief overview of the product.
Interesting. And I think that even the concept of Docker itself, it's all about the speed. It's all about trying to make the life of developers easier. You at Docker are exactly been doing this for more than 10 years. Before we go into the details, I want to have some behind the scenes. How did you came up with the idea of Docker Build Cloud?
As always, we listen to developers, right? And what troubles them, what makes their lives hard, and try to solve those issues, right? To allow them to spend more time innovating. There's data and some surveys that have shown that an average developer spends 1 hour per day waiting for their builds to finish, whether it's their local builds in their inner loop or waiting for CI to finish so someone can, so your pull request can go through and someone can review it. That data led us to start exploring and scoping Docker Build Cloud, and we tried to find a way to improve that by using dedicated cloud machines and collaborating, sharing cache across your organization, across your team, and also using native builders for multi-architecture build or multi-platform images. We managed to get there, as we'll discuss in a bit more detail later.
Yes, this is very interesting, especially in the multi-architectural part, because, for example, I code from this Windows machine, but also from a MacBook ARM-based chip. So I'm interested into this, into having like a consistent build, because I am having something that I need to fix for a Rust project, for example. You know that Rust builds something natively. Having, I think, a build that works everywhere, it's what I'm looking for. I will see, and of course I will check it out. What do you think is the problem the Docker Build Cloud solves?
Slow builds, the consequences. The first one is obviously developers' time is money, but also a CI time is money, right? If your builds take a lot of time in your CI, you will end up paying a lot for your CI runners, whatever CI provider you are using or whether you're self-hosting it. And also it introduces friction in your inner loop, and that results in context switching. You're waiting for your build, or you want to approve someone's pull request, but you are waiting for your build to finish, test to finish. You go ahead and do something else while the build is running, and then you get back to that. Always be converted to costs, whether it's time or money. And those are the two main reasons, two main problems that we are solving.
Thank you so much, Marco. And now a hard question, because the questions so far, they were easier, but I have a harder question to you. Can you convince me to use Docker Build Cloud instead of just, doing my own thing? Now this is your opportunity to try to convince me and also other people watching this video. The question is, can't I just do this with do-it-yourself solution? Where is the real benefit?
Shared caching. So someone from your team or your organization builds a project, then you run a fresh build. That build can reuse cache layers from someone else, or your CI can reuse cache from your local builds. That gives you faster builds. You could maybe host a BuildKit instance remotely or use CI runners with persistent storage or something like that to persist cache and achieve that. The reasons for using Docker Build Cloud would first be it works with both inner loop and CI. You could maybe try to optimize your CI flows in the way that I just described, but to make it work seamlessly with both, your CLI, Docker Desktop, and also in your CI workflows would not be a trivial task, and you get that with Docker Build Cloud out of the box. There's also the ease of use. So you can create a new cloud builder with a single click, as I'm going to show you later. Then you can connect it with Docker Desktop with a single click. You can connect your CLI with your cloud builder in a single command. Then you also have build views, right? An overview and insights in builds across your organization. You can see your teammates' builds, whether in Docker Desktop or in Docker Build Cloud Web UI. You can extract some interesting data, some information from them, see how your organization performs overall when it comes to building images. There's also cost. If you were to do it yourself, you would host a powerful enough machine that can run your builds fast. You would have to maintain it. It would be probably always on, or you would need to implement some non-trivial logic to optimize utilization. With Docker Build Cloud, you get that out of the box as well. You provision your builder. It's always ready to go, but you don't need to worry about the machines behind it and so on. And there's also, as we mentioned, multi-platform builds. When building with Docker Build Cloud, there's no emulation, there's no cross-compilation, right? You build an ARM64 image for your local machine, you run it. From your local machine, connect to Build Cloud, it builds for your machine, then you need to deploy it to a Linux server, which is AMD64. Docker Build Cloud is automatically going to detect a native machine for that architecture, and it's going to perform your build on that very machine. No emulation, no cross-compilation, which is going to reduce the time of your build, but also make it more user-friendly for you. And there's also some optimizations implemented in Docker Build Cloud, like transfer optimization, storage optimizations. If you hosted your BuildKit instance remotely, you would need to upload your build context on it whenever you want to build, and then download architects. Docker Build Cloud is optimized in that way. Your context transfer is optimized, but also pooling your artifacts has a little bit of Docker magic that makes it a bit faster. In summary, those would be the benefits of using Docker Build Cloud over, trying to do it yourself.
You mentioned many benefits, so I was expecting like just 2 or 3, but you went like the extra mile. So thank you so much for sharing this. I will for sure try it out. I'm really interested. I want to work on the same project from here, and then I go to the conferences. I have a presentation that I use Docker there. Then of course I can build both from here and there. But probably having something like this can solve some of my issues. So I will try it out for sure. I have a conference in a week. I see if I can solve it on time. But thank you so much, Marko. Before we keep going with the demo, is there anything else that we forgot? Maybe we can put a link below. And so just to let people know, like, how can you basically get started? And is there anything else or any other way people can know more about this project?
As you mentioned, the best way to learn about Docker Cloud is just to start using it. Extremely easy to do. Just go to app.docker.com/cloud, click Get Started. You can start for free. As a developer, you can start playing around, start improving your builds. And there's also our documentation. You can go ahead, get more familiar with some advanced concepts and how to optimize your builds for Docker Build Cloud.
Thank you, Marko. We will leave a link below in the description. No worries. And I think that now we are ready to show the demo. So see you later.
Let me head over to app.docker.com, select Build Cloud, and then here you can choose your organization or your personal profile. The first thing you probably want to do is you want to create a cloud builder. Let's give it a name and click Create. To start building, all you need to do is to create a BuildX builder that uses the cloud driver. You can do it by running this command in your terminal. So the command will add an additional BuildX builder to my local configuration here. If you have Docker Desktop installed, you can also let Docker Desktop do this for you. You can go over to Builder Settings, and here you'll see a notification saying there's a new builder available in one of your Build Cloud subscriptions. If I click on Connect to Builder here, it will create a local BuildX builder configuration that corresponds to my newly created cloud builder. However, I'm going to do it manually through the terminal by pasting the command I copied from the instructions before. And as you can see, this added a new BuildX builder to my local configuration. I'm also going to make it my default builder, and from now on you just keep building as you did before. So let's build something with our new cloud builder. This is a simple Rust application, a simple web server that returns hello world. And here is the Docker file as well. As you can see, it builds the app and binds it to port 3000. Okay, let's run the build. You can see that the build command and build output are the same as with your local builds, but you can see here on the right side that this build is performed by the cloud builder. If we go to Docker Desktop and open the build view, you can see this build in your active builds tab. So all cloud builds are going to show up in Docker Desktop, and you can see that all the logs are here like with your local builds. And once the build has finished, it's going to show up in the build history tab. When running a Docker build cloud build from your local machine, the image is going to get exported back to your local image store unless you specify otherwise. As you can see, my build command, build output, and build results are the same as before. So if you built Docker images before, there's actually no learning curve to using Docker build cloud. Now let's run our container and see the output. Okay, it's running, so let me go to my browser and check the output. Here it is. Now let's go ahead and change the code a little bit. Let me stop this. So let's change the output to something different. Now if I go and build it again, you'll see that the build is only going to take a couple of seconds because some of the layers have already been cached by our cloud builder. Now let's run it again and see the new output. Okay, it is here. Now let's see how this works in CI. So far, we've been working in the inner loop. We've been running builds from our local machine as part of our development flow. Now let's create a pull request that will trigger a Docker build cloud build from a GitHub action. Now when I create this pull request, it is going to trigger a GitHub action workflow that consists of two jobs, each of them performing a multi-platform build of the project. One job will run a build locally on GitHub Action Runner without Docker Build Cloud, whereas the other job will run a build using Docker Build Cloud. As I mentioned before, each job runs a multi-platform build and outputs two images, AMD64 and ARM64. You can see here that the local builder needs emulation in order to build an image for a different platform. This is the same case as if you try to build multi-platform images locally. When it comes to cloud builds, the builder that we created using Docker Build Cloud Web UI is actually a builder group. So when you run a build, it determines the platform and it chooses a native builder for that platform under the hood. So even when you're building multi-platform images, they are built natively, which means there's no emulation involved, which results in a faster build. And again, you can see all the builds in Docker Desktop. You can see that both of them just finished. This means the job should also finish in the next couple of seconds. Here it is. As you can see, one cloud build took 3.5 seconds and the other one took 43.9 seconds. Let's check the one that took longer. This is the AMD64 build. Since this is a newly created builder and I haven't performed any AMD64 builds for this project on it, there was no cache and this build took approximately the same amount of time as the first build that I ran from my terminal a couple of minutes ago. However, remember when I ran a build from my terminal for the second time and it only took a couple of seconds because most of the layers were cached in my cloud builder? Well, since my local build was an ARM64 build, the other CI build, the ARM64 one, leveraged all the cache I produced while building from my terminal, and that's why it only took 3.5 seconds. This is where collaborative value comes into play. With Docker Build Cloud, you can leverage cache that was produced by someone else from your team or your organization. Or, like in this case, your CI builds can leverage the cache that was produced by your local builds, since both builds use the same cloud builder. And that's why the cloud job took only around 1 minute to build the project for two architectures. And if I were to run it again, the whole job would take less than 10 seconds because now there are layers that have been cached for AMD64 architecture. But also, if anyone from my organization were to build this project on their let's say AMD 64 Linux machine, their build would only take a couple of seconds because they could leverage the cache produced by this GitHub Actions build. You can also see your build history in the web UI. Here you have an overview of builds across your organization. You can see who performed each build, how long it took, what architecture it was built for, how many cache hits, etc. While the local job is running, let me show you the workflow file for this section. As you can see, it runs two jobs. Both of these jobs do the same thing. They build two images, an AMD 64 image and an ARM 64 image. The only difference is that the first job runs the builds locally on the CI runner and the other one runs them in Docker Build Cloud. So there are two main reasons why this build that is running on Docker Build Cloud is faster than the one that is running locally. First, it uses native machines for multi-platform builds, which means there's no emulation, which is always faster. And second, it uses cache produced by other builds across your organization, whether they were run by you or someone else, whether they were run from your machine or from CI. Alright, the local job finished as well. Let's see how long the build and push step took. You can see it took 7 minutes and 46 seconds, while the one using Docker Build Cloud took 1 minute and 7 seconds.
Okay, thank you so much for this demo, Marco. If you have any comments, just drop them below. Marco, some final words, and then we can close this collaboration. Thank you so much, of course, for coming here. I will check it out for sure.
Go ahead, try it. There's no learning curve. You just one click and you can keep building as you have before. It's same old Docker desktop, BuildX, BuildKit, no friction over there.
I really like the idea of having a very similar developer experience, because developer, we think about like new stuff, but we want to have a comfortable environment, so we don't have to learn new things, because sometimes we need to learn so many things at the same time that we would like to have, I don't know, some comfort zone, at least when we use our IDE or our developer development process. Thank you so much, Marco. I will leave all the links below. Thank you so much, of course, for your time, to the Docker team, and see you next time. Okay. Thank you. Bye-bye.
Thank you, Francesco. Thanks for having me, and see you.